Okay, for our next example, what we notice first is that the bottom is not factored. Whenever you do partial fraction decomposition, it's important that you always factor the bottom one first. The reason why is because if you don't factor it, you're not going to know how to set it up with the three rules that we talked about previously. So we're going to factor this one to begin with. This has 4 terms in it. Whenever you have something with 4 terms, probably you want to use grouping method in order to solve that. So we're going to group the first 2 and second 2. We're going to factor both of those separately. So when we write this out, I have 6 minus 4x. And then if I just imagine the first 2 terms there, I'm just going to pull out x squared. That's what goes into just the first 2 terms. And I'll get x minus 1 left. Now I also want to factor the second part. I can pull out a negative 4 from that one. And I want to pull out a negative because I want to get x to be positive, because you're actually trying to match these 2 things together inside the parentheses. You actually will get exactly the same thing. So now I have really a common factor here of x minus 1. So if I want to factor and do the next step, what I'll do is pull out x minus 1 since it's a common factor. So 6 minus 4x over, pull out x minus 1. And then if I pull that part out, what's left over, if I take out the part that repeats, is going to be x squared minus 4. So now I have this. Okay, now unfortunately this is not fully factored either, because this is another thing that we can factor, that's difference of squares. So 6 minus 4x I have on top, I have x minus 1. This is x plus 2, and I have x minus 2. So that's fully factored now. I have all linear factors. That's where we want to get it to. So now that I have it in this form, I'm ready now to write out what the decomposition is going to be for that. I'm going to use rule number 1 here because I have all linear factors. So all linear factors, you're going to do a1 over x minus 1 plus a2 x plus 2 plus a3 over x minus 2. So a question that always comes up that people have is, what if I factor this in a different order? Is that going to matter with my a1, a2, and a3? No, it's actually not going to matter. And the reason why is because if you have these switched, when you go through all the math, it's not going to matter what order, because you're going to get the correct number to appear over each of these linear factors. So in other words, whatever number you're always going to get over x minus 1, it doesn't matter the order in which you have it written. That same number will end up appearing always above x minus 1, and you're always going to get the correct answer. So the order does not matter here. So now that I have it written out, this is the correct form. What I'll do now is I'm going to rewrite that up here, a1 over x minus 1 plus a2 over x plus 2 and a3 over x minus 2. So this is what it's going to eventually decompose into, is that one. What I want to do next is I want to get common denominators with all this. So what I'll do is I'm going to put the factored version over here. Rewrite that, x minus 1, x plus 2, x minus 2. And then over here, what I want to do is get common denominators with all these, because I want to get my big long equation that I'm going to use for either using equating coefficients or convenient values method. I always want to make sure I do that same step every time. So this over here, I'm going to leave it. That's already got the common denominator we're looking for. These here, I want to make this have the same denominator as that one. So I'm multiplying each fraction by what it's missing. So I have x minus 1 down below, but I'm missing x plus 2 and x minus 2. So that's what I'm going to multiply top and bottom by here. So I'm going to do x minus 1, or x plus 2, and x minus 2. Okay, so I'm multiplying that out top and bottom by, again, what it's missing. Next, I'm going to do a2. Originally it was a2 over x plus 2. I'm multiplying this one by what's missing. If I have the plus 2, that means I need to multiply by minus 1 and minus 2 here. X minus 1 and x minus 2. So that's what I'll do here. Okay, so now I have that. Next, I have a3 over x minus 2. And I'm going to multiply this one by what it's missing. Now I have the minus 2. I need to multiply by these first two, x minus 1 and x plus 2. So I have x minus 1, x plus 2, x minus 1, x plus 2. Hopefully you can see that. Go all the way to the edge here. But that's basically what you'll have there. So now I have everything has the same denominator. So because it has the same denominator, I can now eliminate the denominator and write out my equation I'm going to be using for either one of my two methods. 6 minus 4x, so I'm going to do that here. 6 minus 4x is going to equal a1 times x plus 2, x minus 2. I have a2, x minus 1, x minus 2. And then I have a3 times x minus 1, x plus 2. So that whole thing, this is the actual equation that I'm going to be using when I do my methods. So this problem is going to be done a lot easier by using the convenient values method. We don't want to use equating coefficients. We could, but because I have three variables, that means I'm going to end up getting a system of three equations and three unknowns, and I probably need to use matrices and all that to solve it. We're not going to get into all that in this class. So to make it easier, I'm actually going to do this problem by convenient values method only. So that's how we're going to proceed here. Okay, so now we're ready to start putting in values. We're using the convenient value method. So the first thing you want to do is you want to pick a value for x. So we want to pick a convenient value that allows something to cancel and get a 0. You just look at the parenthesis, and this is how you're going to tell what values you're going to pick. We want to pick -2 there, because -2 would allow me to get a 0 here, and that would cancel that part out. So that's kind of how you would know what convenient values. You just look for whatever makes the inside parentheses equal to 0. Let's put -2 in on both sides of the equation. So we're going to do 6 minus 4 times -2. I'm putting -2 in there for all the x's. Okay, so what I did was, every single x on both sides, everywhere I have an x, I put -2 in for each one. So we want to make sure you use the same value on both sides. So I'll give you a second to kind of let that soak in there. Let you see that. And so now we want to start cleaning this up and simplifying both sides. This part I have 6 plus 8 will end up being, so we're going to get 14 there for that one. Now, every place I see -2 plus 2, I can go ahead and cross out that term. The reason why -2 plus 2 is 0, and 0 times anything is 0, so that whole term is going to cancel out. I can do the same thing over here too. -2 plus 2, that cancels out. That's going to give me a 0 also. So all I have left is a2, and then I'm going to go ahead and work this out for each one inside the parentheses. I need to do that first before I multiply them. So I'm going to get -3, and then I have this is going to be -4. What I get when I multiply out, I get 14 will equal, this is 12 times a2. So I'm going to divide both sides by 12, and I get my value for a2. So when I do that, I can divide a 2 out of each of those, and I get 7/6 for my value for a2. So a2 is 7 over 6. Now that I have this value, I'm going to keep on going and pick other values for x, so that way I can find a1 and a3. Okay, next convenient value, we've already tried -2. This time I'm going to put in 2 for x, because that way that I can see that would also make that part 0. So I'm going to let x equal 2. I'm putting 2 in there for all the x's on both sides. So we put a 2 in on the left hand side, and now I'll put in a 2 for all the x's here. So a +2 I'm putting in this time. Okay, so I've put in a 2 for all the x's on both sides. I have these two here, these two, and these two. Same number, you gotta make sure you put the same number all the way through for all the x's. So now that we have this, we're going to go ahead and start simplifying. This time I have 6 minus 8. That's going to give us -2 here. Every place I see 2 minus 2, I know that part's going to give me a 0, and 0 times anything is 0. So this whole term here with the a1, that's all going to cancel out. This term with a2 is all going to cancel out also, because again I get another 0 there. I'm left with this. I have a3 times 1 That's the part inside here. And then this part is going to be 4. So I get negative 2 is equal to 4 times A3. I'm going to divide both sides by 4. And when we do, we get negative 2/4 or negative 1/2. So A3 we found this time. A3 is negative 1/2. So I'll go ahead and I'll write that up here now. We found A2, A3. Now we just have to find A1. So we need to pick another value. Okay, we've already tried negative 2 and positive 2. I notice there's another value I can put in that will cause something to be a 0, and that's going to be the value of 1. So now, let's pick x is equal to 1. By the way, you can pick these numbers in any kind of order. It just means that you'll solve for different coefficients in a different order. It doesn't matter. So it doesn't really matter that I started with the value of negative 2 first and plugged in, and I could just as easily start it with 1 or negative 2. It doesn't matter the order in which you put these convenient values in. Now let's do x is equal to 1. We'll put a 1 in there for all the x's. So I have 1 there. I have 1 plus 2, 1 minus 2. 1 minus 1, which is going to turn into a 0. And this one's also going to give us a 1 minus 1. Will give us a 0 as well. So I put a 1 in there again. All the x's, I put in 1's. And when I simplify, I look for the one where it's going to give me a 0. This part right here, 1 minus 1 is 0. That whole part's going to cancel out. 0 times anything is 0. This whole part, same thing. That whole part will drop out as well. I'm left with 6 minus 4. That's positive 2. And in this part, I end up with 3 times negative 1 there. And so I get 2 is equal to negative 3 times A1. Divide both sides by negative 3, and I get negative 2/3. That's my value for A1. So now what I've found is I found all my values. I have this. So now that I've found all my values, we're now time to actually write it back and write our final answer. So I have these that I found by working through my convenient values, and I'm going to go ahead and erase this because I'm going to plug my values back in to the original one. So if I erase all this here, I'm going to be able to put my values in. So I'm basically going to substitute the values in for A1, A2, and A3. So A1 is negative 2/3 over x minus 1. A2 is 7/6 over x plus 2. And then A3 I have is negative 1/2 over x minus 2. Now you probably don't want to leave your answer in this format because you have a fraction over a fraction. So technically what you want to do is think of this as, you can always write a fraction over 1. And we're going to take the top fraction, multiply by the reciprocal of the bottom one. So that way we can get rid of our double fractions. So that's going to be negative 2/3 times 1 over x minus 1. And then plus 7/6 times 1 over x plus 2. And then I have negative 1/2 times 1 over x minus 2. And I have this. So I can leave my answer like that, or again, if we want to go ahead and multiply that out, I can do that as well. But let's go ahead and multiply across the top, across the bottom. I'm actually not going to multiply it. I'm just going to go ahead and leave it in the factored form here. And that's going to be, this right here will be my final answer. So going through that, I've gotten rid of the double fractions, and this is the better way of writing your answer. And if you use that online homework grading system, it's going to expect that you write your answer out on this form as well. So we took this original one here, we broke it up into A1, A2, A3, we found out what those are. So now again, if I take this, get common denominators, go through all that work, I should end up getting the same exact fraction that I started with.